cars, unmanned vehicles, or the automated cars. The first concept of self-driving cars was proposed by General Motors in 1939. And interestingly, it's an electrical vehicle. And we want to add one more thing to it. General Motors only made this concept to a real car in 1958. And after that, there are not too many things happened for autonomous driving. And things have been changed in 1980s because of a person named Ernst Dickmann. He is the pioneer of modern autonomous driving, and I showed his picture on the left. Ernst worked at the Bundwehr University in Munich. He created an autonomous car with Mercedes-Benz, and the car weighed about 5 tons at that time. In 1986, the autonomous car from Benz can drive itself, and it can drive up to 60 miles per hour in 1987. So finally, at the end of 1995, this car can drive a trip of 1,758 kilometers, and also 95% of the trip, the car is driving by itself, which is really what we defined as autonomous driving. And you can see the car on the left, and there is a very good book related with this topic, and the author is Ernst Dickmann. And in 1990s, not too many progresses happened because most of the time, the autonomous driving were performed by research funded at university level, not the government or federal level. US and Italy both are working hard to catch Ernst's research during that time. And I showed 2 vehicles. The lower vehicle is the vehicle created by Carnegie Mellon University, and 98% of the time, it can drive by itself. So comparing with Ernst's result, 95%. In fact, at the same time in 1995, CMU almost beat what's the first electric vehicle. Okay. Meanwhile, in 1996, University of Parma proposed another autonomous vehicle. This vehicle used 2 cameras to look at an object, and 94% of the driving time is autonomous. Okay, the most exciting part for autonomous driving came to the new century. DARPA released a ground challenge in according to the mandatory congressional request, because they said all US military ground vehicles will be unmanned vehicles by the year of 2015. So to address this request, in 2004, DARPA hosted the first ground challenge in Mojave Desert. However, this kind of ground challenge is failed almost. No team finished the course. The total course is 150 miles, and only CMU finished about 7.3 miles. Okay, it's far from a success. Okay, and the second ground challenge was also hosted by DARPA and was held in Mojave Desert again. And in this competition, 5 teams finished, and the winner was the Stanley, which was created by Stanford University, and it finished 132 miles in 7 hours. Okay, and I showed their cars also on the right. Okay. The third ground challenge was held at George Air Force Base in California in 2007. The winner was again CMU, and the car named Boss, and finished 4 hours over the 60 miles urban course. Comparing with the first, second, and the third grand challenge, we can see the first 2 grand challenges were held in desert. Why? Because people were not confident at that time. They were worried about, is there going to be a lot of crashes? And it did happen. If you look at the videos of the first 2 grand challenges, many cars roll over and they lost, or they just kind of turn around on the spot, okay? And the third one, which is more challenging because for the third competition, the course is not in the desert, it's more like an urban course, okay? After 2008, autonomous commercial vehicles were commonly used in mining operations to save manpower and also to avoid any accidents. And you can see that since 2003, the release of DARPA Ground Challenge to 2008, 5 years, US has been the leader of the autonomous driving, and this kind of leadership continues after that. And let's look at what the CMU vehicle did during the 2007 DARPA Ground Challenge. And in that car, they have 4 layers of control. The first layer is going to be the motion planning, which executes the current motion goal. For example, are you going to move forward, go left, or go right? And also, the second layer is the trajectory generation. People will look at the model predictive trajectory generator. This is the exact name they used for their software. And at that time, think about GPS in 2007 was not that common, though it exists, but was not that common for civil usage. And they use all kinds of sensors to predict what will happen on the road. Will there be any obstacle? Will there be any pedestrian? Or is there any kind of bump on the road? And also the on-road navigation creates curve along center line and aligns rear tires. The reason is because when you turn around on the road, you have to make sure you're not going to lean on the road. So this is going to be more like motion control. And the last level of control is zone navigation. Zone navigation will majorly work if there is no landmarkers. So basically, if you are working on an urban course, there must be different lanes or lane markers to guide the car. But if there is no such markers, then they develop an anytime D-Star software package to handle the situation. And one important lesson the CMU team recommended is never makes any assumption about objects, whether the object is moving or not moving. And based on these developments in the history, so what are we expecting to see right now? What is the expectation for autonomous driving from our current viewpoint? There is a very good animation on YouTube, and I'm going to show it to you guys.
Self-driving vehicles can detect obstacles and stop if necessary. With the help of sophisticated technology, vehicles from Navaya, Waymo, and local motors are able to pick up passengers on demand and take them to their desired destination. Autonomous vehicles are also able to recognize traffic lights and road signs at intersections and act accordingly. But how do they actually do all this? Self-driving cars do not require a driver to get from A to B. The technology in and on the vehicle is the driver. The technology includes many sensors, such as LiDAR sensors, ultrasonic sensors, cameras, and radar sensors. The sensors are located at the front and the rear of the vehicle. Cameras and LiDAR sensors are also frequently found on the roof. Without them, the vehicle would be virtually blind. LiDAR is a key component in many vehicles. LiDAR works similar to radar. LiDAR, however, does not use radio waves, but many light rays that are reflected by the objects in the surroundings and detected by the LiDAR sensor. In this way, a point cloud is generated from the environment. However, LiDAR does not recognize road signs. Cameras use artificial intelligence to recognize and interpret street signs. Cameras are also used to detect obstacles and are needed for lane keeping. Neither LiDAR nor cameras can handle fog. In this situation, radar is needed for forward collision warning and avoidance. A major disadvantage of radar, however, is that the objects must be large enough to be detected. Pedestrians or cyclists may therefore not be recognized by radar. The exact position of the vehicle is determined by GPS and highly accurate digital maps. Digital maps contain a lot of information, including information such as intersection signs and speed limits. Since GPS cannot always be guaranteed, for example in tunnels and street canyons, odometry is also necessary. For example, the wheel diameter and the wheel speed can be used to estimate the future position of the vehicle. All data from sensors are then combined and processed in one or more processors. NVIDIA, AMD, and other manufacturers offer such chips for autonomous driving.
Okay, so that's the video I want to share with you what the autonomous driving people are expecting right now. And also in the near future, we can see there will be a lot of announcement of technology development from leading car makers. So Binance and Tesla already provided the autopilot driving, especially Tesla is the leading car manufacturer for autonomous driving. And also, besides Tesla, a lot of car makers are expecting to release the autonomous driving assistant featuring steering, braking, and lane guidance within the next 3 years. And Google announced a long time ago they're going to release Google Car, which is autonomous driving this year. However, I haven't seen that yet. So they may release it within 5 years. And also in the next 10 years, fully autonomous cars are expected. Okay, so these are all the announcements from high-tech companies. They want to release the autonomous cars. Okay, however, will it be true? Will this happen within 10 years? Okay, so the reality here is if we want autonomous driving, we need computers to replace human beings. And when autonomous driving is fulfilled, we need at least cameras, as we showed in the video, to detect the lane markers like stop signs. And these videos need to be processed by computers on the car. So currently, we don't have a high-performance computer. Okay, if we include the high-performance computer in each car, the car price will increase a lot. And the second condition we have is the videos or the images taken by each car is processed by the individual car itself. There is no information sharing, and because no collaboration of image processing, the process speed of the image is slow. And without sharing of the video information among cars in adjacent to each other, the road situation is pretty hard to be determined. And the third condition we have right now is the current communication infrastructure. So here in US, we are more on 4G. In Europe, people are more reliant on 3G. With the 3G and 4G communication, in fact, when you look at 3G, 4G, it's the third generation or fourth generation communications infrastructure, okay? And the 3G, 4G communication infrastructure will have a lot of communication delay, which is going to be at least 10 to 30 milliseconds, okay? And this is depend on the traffic load of the wireless communication. And also, if we share a lot of images, this will significantly increase the communication latency, okay? And the last thing that have happened in the reality is autonomous driving is not just a development of technology. It's not just planning the trip, control the vehicles. It includes many safety concerns. And that's why even we have autonomous driving, most of the car makers, they still provide the fully human driving mechanism for the car. Based on these current conditions of the autonomous driving stage, what is going to be the challenge and knowledge gap we need to fill and to expect a fully autonomous driving mechanism in the future? So currently, the poor road infrastructure provides no real-time road conditions and traffic conditions. You can see normally when we drive a car, you can hear the radios will tell us which part is blocked and what's the expected delay time. And these can be modified by having a better road infrastructure. Unfortunately, car makers are working hard to improve road autonomy in big cities. So in Texas, I think Austin and Houston, there are a lot of ongoing projects related with the road autonomy. And this is not going to be good enough. Why? Because 80% of the highways in the United States are not in the city. Okay, so in order for a fully autonomous driving in the future, it means 80% of the road in the suburban area should also have a good infrastructure. And another thing we want to say is currently we only have human driving or human drivers on the road. In order to have autonomous driving in the future, lawmakers should work hard to have more regulations to regulate autonomous vehicles when they are on the road. Okay, and the third challenge is a communication system needed for the fully autonomous driving. And this is going to be the most possible method. We have 5G communication right now. With 5G communication, the communication latency is significantly reduced to 1 millisecond. And the last challenge is how can we do the fast and accurate data process, and deep learning gives us a promising way to do that. And we're going to see next, so why we need 5G communication and deep learning for autonomous driving. And the reason is because we need to follow a 3-second rule for safe driving. And I have to say this video only gives you the information of safe driving, and there is no advanced technology of trajectory planning. So let's look at this video, which is going to be a fundamental layer as shown in the CMU car, which won the 2007 Grand Challenge competition. I showed you they have 4 layers, and this is going to be the fundamental layer to look at how we can have the collision-free trajectory.
Many people think that they are going to arrive at their destination sooner if they stay within inches of the car in front of them. Following too closely, or tailgating, is one of the leading causes of traffic crashes. To avoid tailgating, follow the 3-second rule. It takes 1.5 seconds to notice a risk, and another 1.5 seconds to hit the brakes and slow down to avoid it. There are your 3 seconds.
Okay, so I'm only going to show you why we need that 3 seconds rule. If you're interested in the video, you can check with me later because this is a long video. I don't want to show all of them. Oh, sorry. Okay. So in the previous video, we already see the 3-second rule, and I have the screenshot of the 3-second rule. The first one shows if you have one car and then it needs 1.5 seconds at least to make decisions. And this 1.5 second rule was published by a paper to look at the response of human beings. It's not for any traffic study, but it's for a psychological study by NIH. And also the second 1.5 is going to be when your car is going to be drive at 35 to 55 miles per hour, it takes at least 1.5 seconds for you to stop your car and don't collide with the car in front of you, okay? And with the 3-second rule, so if we want to replace human beings with computers, the first 1.5 seconds is going to be
it's being recorded.
it's a very, the most important time period for us to command our computers. Okay, so let's look at if we want to replace human beings with computers, what will computers do in this 1.5 second? Okay, so the first thing the computer will do is take images of surrounding environment. And then the second one is going to process images for distance and also the velocities of other vehicles nearby. And the third is going to be the computer will determine whether it's going to be decelerate or change line based on other vehicles' location, velocity, and the road condition. For example, if you have icy road, it takes much longer for you to stop, okay? And then after it makes a decision, the computer will send command to actuators, and then your car, the actuator is going to be the brake of your car. Your car will stop or change line, okay? And how can we do this with computers? And as we said, if we have a high-performance computer in the car, it's expensive. The current mechanism for us is more like, can we do parallel computing or can we do cloud computing? We're going to send all this information to the cloud because in cloud, there are numerous computers which can process the information at the same time. So this is the task we want the cloud computing to do. So send the image to the cloud-based decision-making will be performed, and then it will send the command back to the cars within the 1.5 seconds. As we said before, because we're going to send image to the cloud, receive command from the cloud, so the communication delay is going to be a very important factor for us to consider. Fortunately, with the 5G communication network, the communication delay will be less than 1 millisecond, okay? And then it says within this 1.5 seconds, you can make the decision. And the communication delay only count like little bit, 1 millisecond, right? Okay, the rest 1.5 seconds, you need to do the decision making. And then you think about 1.5 second is tick-tock, it's done. Can your car or can any computer do this decision making within this tick-tock? Okay, so it's still a very challenging problem for us. And what people proposed is a 5G based deep learning algorithm. So 5G is like a backbone to support our future smart living. Everything will be based on the 5G network. And numerous companies, including Verizon, Sprint, if you look at online, they all release their 5G network kind of introduction already, okay? And another thing people propose to say, within that 1.5 second to make decision, we must have very fast data processing method. And deep learning was developed and proposed during the past 5 years. Deep learning was really proposed in about 2016. And at that time, people started to look at the facial recognition or speech recognition, and it was originated from image processing society. And deep learning is like a muscle for the autonomous driving. With 5G communication, we have the bone, but without muscle, the bone cannot move. So with deep learning and 5G communication, it's muscle with the bone can move to whatever direction you want, right? And 5G communication, deep learning combining together provides a promising way for autonomous driving. And the next question we want to say, how does 5G communication work? And there's another video I want to share with you.